Welcome to week 4. We're doing proportions. Week 5, we may or may not do percentages. I'll send out an email after class if we want to do our midterm a week from today or later on. We talked about that a little before recording. But for now, let's look at week 4. In the textbook, the 4th chapter is a mishmash of stuff named formulas and equations. And we did a bunch of it earlier in week 3, but now we're finishing up. We have proportions is the main thing. Variation is sort of like proportions with a little extra wrinkle, and then a tiny bit of graphing. We don't have any links yet, but they will go here when they are. And as always, for each of the textbook chapters, whoops, that shouldn't say 2. Okay. Oh, I don't have my saver on. One moment. Okay. Now we have for each of the 4 sections where we are in the website. And my job today is to go through this at this ridiculously fast pace to show you all of the places that you might trip up on or somebody might not have taught you well enough in the past through no fault of your own. The to-do list looks exactly the same. You're here, hooray. Do a study group if you can, or check in with me for just a few minutes in Zoom, especially if you're someone having real life issues going on so you don't fall through the cracks. Do as much of the homework in the book as you need. Then when you feel like you're finally ready and getting all the answers correct, which you can tell because the odd answers are in the back of the book, then go on. Look at the Being Mather page again. We went over it just a moment ago off the recording. And then you have 10 problems step by step to write out neatly. Those have been excellent so far. Thank you for getting them done. Whether or not your accuracy is good, then it's nice to have those. If you need another reminder of where the Google Drive is, where you can look at other people's nice step-by-step answers, let me know. I can send out, should I just put that in my to-do list, reminder in the after class email about that? Some of you have very nice written work, and if you want me to put your step-by-step answers in the Google Drive and they're not there yet, so you can show off, feel free to do that. Then only one set of 10 exercises for this week. And keep track of achievements if you need it. Okay, are we ready to get started? I'm going to start with ours because of how it's organized, and then go look at the textbook versions before we're done with class today. So we're just going to start with proportions and cross multiply. Okay, a proportion is an equation of the format ratio equals ratio, or whoops, rate equals rate. So I'll put that on our Jamboard. So here's an example: 7 miles over 2 hours equals 35 miles over 10 hours. And unfortunately, it's much easier to read these if you write the formula with one number directly on top of the other. With HTML, I have to make slanted fractions. That's how websites work, but that is terrible. Don't do that. Put your things one on top of the other. So I would write the example proportion on my paper as 7 miles, whatever it was, 2 hours. That's very slow. Equals 35 miles over 10 hours. Oh, so up and down, not diagonal. And the most common thing to do with a proportion is to play this game involving multiply in an X shape. So you've probably seen this already. Most people have by the time they get to LCC. So let's look at one of these. This is claiming, is 2/4 the same thing as 5/10? If I was to just ask that without mentioning proportions, 2/4 is 5/10. If I gave that to my 10-year-old who's never seen proportions, I don't think, in class, then what would his instinct be? How would you check if these two really are the same?
Just reduce them so it equals out to be the same.
Yeah, if I said divided by 2 top and bottom, I would get both of them are 1/2. Whoops, not 2s, that's 5s. So that's 1/2. This is 1/2. They must be the same. They're both 1/2. What's another way to do it if they didn't reduce friendly?
You could find a common denominator.
Okay, I could multiply each one by the other. We did that as the brute force method when adding fractions or subtracting fractions. And if I do something to the bottom, I have to do it to the top. So they both turn into 20/40ths. So yeah, they must be the same. So we already have at least 2 ways to do this. But now there's this claim that if I'm trying to check this, here's a third way. I'm going to multiply this diagonal, 2 times 10, and I'm going to multiply the other diagonal, 5 times 4 or 4 times 5, doesn't matter which order we multiply things. And if those are the same, then my original fractions were also equal. So raise your hand or shout out or something if you've never seen this before. Is this old material?
It's old material.
Okay, so I'm going to ask you, why does it work? Why can I multiply diagonals to check if 2 fractions are equal? Rick has his hand up.
I have a guess, but I'm not sure if you're cross multiplying that way, isn't that the same thing as you're multiplying a reciprocal? And so if they're 2 divided by 4 times 5 divided by 10, or cross multiplying is the same as multiplying it by 10 divided by 5. So you're hoping to get 1. I don't know. That doesn't really make sense. That was just a guess.
It might make sense. I see where you're going, but that's way too complicated. Here is your hint. Here is a 2 times 10. Here is a 5 times 4. How come we don't care about the denominators?
Since by using the brute force method, we've made the denominators the same. We have 4 times 10 and we have 10 times 4. They're going to be the exact same once we
Yes, Rick got it. If we multiply each denominator by the other, of course they're going to be the same. 10 times 4 and 4 times 10 will be the same. We don't have to check that. All we have to check is that when we make things fair by multiplying the numerator by the other denominator, does that equal or not? So all we're doing is what we did on this slide, this brute force method of finding common denominators, but we're not writing the denominators. We don't care that this is 20/20ths on both sides because we are, whoops, not 20ths, 40ths. It would help if I said the right thing. Actually, it would help if I write things. Okay, 40th. We don't care that it's 20/40ths on both sides because of course it's going to be 40ths. That's just what happens when we multiply one by the other. It's going to be something that's the same on both. So if we're just checking for if they're the same, we don't care about the denominators. We will not write it. And that's all that cross multiplying is. It's just the numerators of finding common denominators. Okay, whether or not you get it, let's move on. For some reason, we need another word. Equal is a perfectly good word, but we also use proportional. Two ratios are proportional if they're equal. If you're into philosophy, I should also mention that equal doesn't mean exactly the same. You might think it does, but if I write something like 2x equals 6, then this is a constant, and this is an expression. How can you have an expression and a constant philosophically be the same thing? So anyway, ignore that. I'm messing with your brain. But proportional also means equal. So let's do a few of these just to check. Are they true or not? I'm going to rewrite them so that they look better. 4/9, is that the same as 12/28? So I will have one diagonal here, 4 times 28. Is that the same as my other diagonal, 9 times 12? Take out your calculator if you need to. What's 4 times 28?
112.
Okay, and 9 times 12?
108.
So no, they're not the same. Does it matter if they have decimals? No, exactly the same thing happens. You have calculators, the decimals are not scary. If you're trying to do these by hand without a calculator, don't waste your time. Get out your calculator. So one diagonal, 7 times 7.2. Is that the same as 9 times 5.4? Okay, somebody tell me what these are.
7 times 7.2 is 50.4. And then 9 times 5.4 is 48.6.
Okay. So also a no. If all we care about is yes or no, we don't even have to necessarily do all the multiplying. 7 times 7.2 is going to end in a 4 because 7 times 2 is 14 and some carrying will happen. 9 times 5.4 is going to end in a 6 because 9 times 4 is 36 and some carrying will happen. So, okay, is everyone okay with these? You could do more of them on homework if you needed to. Okay, this is kind of stupid though. No one in real life is ever going to say, are these two fractions equal to each other? So what we really care about is the ones that have variables in them. So this looks the same, but philosophically is very different. And this is what actually happens all the time in real life. Here is a rate. Is it equal to the other rate or not? So the first thing to notice is there's no question mark over the equal sign anymore. I'm not checking if something is true. My job is to force it to be true. There's some number that I can plug into y that will make this true, and I am going to be a detective and find it. Then everything else works the same. I have one diagonal, and I can write y times 8. I have another diagonal, and I can write 3 times 32. So y times 8 is whatever that is, 96. And then we've talked about these before, these one-step equations. Something is stuck onto y with times 8. So I will do a divided by 8 on both sides. And what's my answer going to be?
12.
And back to what Rick was mentioning earlier, I can plug it in and see if it makes sense. Is 12 over 32 the same as 3 over 8? Sure, turn them into decimals, do cross multiplying, however you want to check them. Okay, questions about this one? No, okay, my time to talk a lot. When I was just checking, I would often write things to the side just because of how my paper is shaped. But I really want you, when you're solving proportions, to line up everything. See how my equal signs line up, my y's line up. Keep yourself organized and you won't make careless mistakes. So how you write it on the page will really help you with these. Another detail, I use dots for multiplying. You can use little x's if you want, but whatever you do, don't make it look confusing. I want your multiplying dots and your decimal dots to look very different. If you're using x's, I want your multiply x's and your letter variable x's to look very different. So this is where it finally gets to be neat handwriting matters. That makes sense as a warning? Especially when you're working in groups or doing something that's getting graded. If I can't tell if that's a decimal or a multiplying, or the people you're working with can't, they'll get confused. Okay, next thing, you have superpowers. Does it matter which diagonal you put on the left or right side of the equal sign? No, if something is equal to something, it doesn't matter what order I write them. So you can pick either diagonal to go on the left or the right side of the equal sign. How about in each diagonal? Does it matter if I write y times 8 or 8 times y? Does it matter if I write 3 times 32 or 32 times 3? No, multiplying, I can switch the order and it's fine. So when I put these together, let's do another one. I have the ability to say whatever diagonal has the y, I'm going to put that the way my brain works on the left-hand side. And whatever I pick for that diagonal with the y, I can put the y first. And that way, my second step always looks like one of these equations that makes my brain happiest of y times something else equals something else. I never have to worry about the y being in the middle or on the wrong side or something compared to just how I go when I'm on a roll. Okay, 1.3 times 96, 124.8. Get y by itself. $104. Oops. Okay. Everyone happy with both my example problems? You don't have to use fancy colors like I do. I am lecturing, but realize you have these powers. You can pick whichever diagonal you want to be on the left. You can pick whichever item inside the diagonal to be on the far left. So I always put the y there just because that's how I am. And if you don't have any habits, I encourage you to have that same habit. Keep your equal signs lined up, keep your y's lined up, and you won't make careless mistakes as much. Other questions about those? Okay, onward. The cross multiplying is a tricky thing only because of disagreements of language. Some people will call this the cross multiplying step. I have turned something with fractions into something without fractions. Other people will call the whole thing cross multiplying. That's the process to get my answer. So at LCC, everyone has agreed that we're just calling this step the cross multiplying step. That way, if I need to talk about it specifically, I have a word for it. You don't really care. There's also a shortcut. Does everyone know the shortcut of how to get to this without having to write so much? If you do a bunch of these, you will discover the shortcut on your own. Y over 96. So the shortcut goes that there are two things that don't have the y involved. So for those, I'm going to multiply. And then there's something that's like the odd number out that's opposite the y. And that one I will divide. And that's exactly what we did, by the way. So if you're not sure why this shortcut works, just do a dozen of these and you will see that you always wind up multiplying first and then dividing by the thing that was opposite y, and you'll see how it works. Can you use the shortcut? And the answer is it depends on what your future plans are. If you are going into any class that has some algebra later on, then you really want to write the cross multiplying step. Because if this wasn't a y, if it was instead a y plus 1, then that changes things. And I'm not going to talk about how. But if there's any chance there'll be more stuff happening than just a very plain, boring proportion, then you don't want to jump ahead and rely on the shortcut. I would talk more about that if I had more time, but I don't. On the other hand, if this is your last math class and you're never going to see proportions that don't just have a plain, boring y right there, then go ahead and use the shortcut. No need to write out 3 different steps. It's also true that I can cover up this step. See if I can make it work. No, that doesn't work. Okay, can I make a white box? Does that cover it? No, can I fill it with something? Oh, well, you get my point. If I cover up the line I'm trying to cover up, you could still follow my flow of thought. I have this, I'm dividing by 1.2, I get to y. I multiply these, I divide by 1.2, I get to 104. Does that make sense? And if I, on the other hand, covered up this, then you could see what happens. We put these together, we divided both sides by 1.2, even if I am not writing it, and you can see what happens. If I, on the other hand, cover up both of those middle steps, then I'm covering up too much. I'm not quite sure how I got from this to that. That's just a little too much in my head. So if you're writing neat steps, don't cover up both of those, but you can cover up either one you want. You can ignore this line if you want, or you can ignore that line, or you could write it all. Okay, but now we need to get to the real actual part. So word problems is what we really care about. So here we have 4 different word problems. Somebody has tried to make proportions that are accurate representations of these word problems. For each problem, 2 of them work and 2 of them don't. So stare at them a bit and tell me which ones work and how you know that. And I'm going to put this on the next slide also, because I know I will need to do that. Why isn't it? What are your ideas? Let's just kind of go one by one. Does that one look good? Why or why not?
It does, because if you do 40 times 2, it's 80.
Oh, okay. How about, yeah, so she's cross multiplying in her head and seeing that it works.
Yeah.
How about the next one?
I think it's the same thing.
looks okay by cross multiplying. How about the third one?
That one wouldn't work.
No. 40 times 80 is not 2. So that one doesn't work. How about the last one?
It doesn't work.
So if we didn't want to cross multiply to check, is there any other patterns we can see? If we had more time, if we were at a Math 20 pace, I would let you stare at this and figure it out yourself. If you have kids or other people that are trying to learn this, I encourage you to let them stare at it until they figure it out. But just because we're in this double speed silly class, I am going to give you big hints. One situation is 40 miles in an hour. And I'm going to put an arrow there to kind of represent that miles is first and hours is second, the way I read it. Another situation is 80 miles in 2 hours. With me so far? What happens when I draw my arrows on these things? 40 miles an hour, 40 miles an hour, 40 miles an hour, 40 miles an hour. 80 miles in 2 hours, 80 miles in 2 hours, 80 miles in 2 hours, 80 miles in 2 hours. Okay, someone describe what's happening.
The two that are right, the arrows are going in the exact same direction.
Yes, we like it to be symmetrical. We want either one side of the equation has one situation and the other side has the other situation, and the arrows go the same way, right? If we say miles first, we keep saying miles first. Or we like the top being one situation and the bottom being the other situation. And again, it goes the same way. It doesn't work if they go opposite directions or if they cross beams, like Ghostbusters. For almost everybody, this feels the best. One situation on one side, the other situation on the other side. If it says miles first, it stays miles first. If it says hours second, it stays hours second. A very few people have brains that like this one, where one situation is on top and the other's on the bottom. If that's you, I am sorry. I'm never going to write it like that. That's going to confuse too many other people. But that doesn't mean it's wrong for you. But I'm always going to do this style because that's what works. So let's just check the other ones. So 12 tests in an hour, 12 in 1, 12 in 1, 12 in 1, 12 in 1. 36 tests in 3 hours, 36, 3, 36, 3, 36, 3, 36, 3. Which ones are going to work?
2 and 3.
Middle.
Those have parallel arrows. The others are not going to work. You with me? So when you are setting up your own, then your job is to learn from this. So I'm going to start by making the skeleton of a proportion. Fraction bar equals fraction bar. How do I know to do that? because I've read the problem and it has 2 situations and it gives me 3 out of 4 numbers. The first situation was 120 calories per 1 serving. And at that point, I stop reading. I don't care about anything else. I know that there has to be calories on the top and servings on the bottom. So I will write that in so I can't make a mistake. Right? The arrows have to be parallel. Then I keep reading. A whole bag has 3.5 servings. How many calories? Let's look at the next one, just setting it up. So 2 situations. They give me 3 of the 4 numbers. This is going to be a proportion. So I write the skeleton, fraction bar equals fraction bar, and they start reading. When pediatricians prescribe acetaminophen to children, they prescribe 5 milliliters for 25 pounds of the kid's weight. And then I stop reading. It has to be milliliters on top and pounds on the bottom. So I will rate that before I keep going so I don't mess up. Then I continue. If Zoe weighs 80 pounds, how many milliliters? If you flip over the first fraction compared to your neighbor, it works just fine. It's not like there's anything about mils or pounds that make it inherently top or bottomish. But if you flip over one on this side, then you'll wind up flipping the other one too, because you have to make your words match. The hardest ones are like problems 53 and 54, these catch and release problems, because the temptation is to put everything with the same number, same label. If all of your words are fish or deer or whatever the other animal is, you have no idea if you put your numbers in the right spot. You have to think of slightly more complicated labels. Otherwise, you're just shooting blind here. Oh, it says videos twice. I will fix that later. So again, you have videos online if you need help with these. If you're one of the people that got the textbook, you can do some practices there. And I want to talk about 3 different ways to solve this, because just because we're doing it with proportions now doesn't mean this is the only way to do it. And some of you are going to get frustrated because you like other ways better. So some people say, oh, by the way, I am on purpose not finishing and solving these. Is anyone really upset by that and wants me to spend some minutes doing the rest of them? No, okay, holler if you will. I can always keep recording after class. Okay, a bug crawls 36 feet in 1.8 minutes. How many feet would it crawl in 12 minutes? Let's do this 3 different ways. Some people really like finding unit rates. They will say 36 feet in 1.8 minutes. 36 divided by 1.8 is 20 feet per minute. And then they will say, oh, look, there's a times 12. So I'm going to do a times 12 and get 240 feet. If that's you, if you like making unit rates, you can do these problems that way. Some people will do the same thing, but they like unit analysis, which we haven't really talked about too much this class. We'll get to that soon. So a bug crawls a certain amount. The fixed thing that's specific to this situation is that we have 12 minutes. Is that a fraction? No, so I put it over 1. I need to get rid of minutes and go into feet. So I'll put my minutes on the bottom so it cancels, and my feet on the top. And how do I get from minutes to feet? There's 36 feet for every 1.8 minutes. I have feet on the top, all my units on the bottom have canceled out, and I will get the same thing, the 240 feet that way. If that's how you like to do these, that works too. You're allowed to do it that way. And lastly, the thing we just talked about, the proportion. Two situations, 36 feet, 1.8 minutes. How many feet? Well, first I should stop, put my feet in minutes where they belong. How many feet in 12 minutes? So y times 1.8 is 12 times 36, and do my math, and I will get the 240 again.
I believe it's actually 336, just to make sure the math is right.
It's
It's not 240 because 12 times 36 is more than that. 28 times 12.
Oops, 12. That's right.
Oh, excuse me. I'm sorry. I had the wrong numbers put in.
Okay, so for almost everyone, cross multiplying just satisfies some sort of primal thrill, and everyone likes cross multiplying. And my job as a math teacher is to help you not cross multiply when you're adding fractions and things that aren't cross multiplying situations, because you want to cross multiply. But if you are somebody that likes the other two ways, that's fine. Those ways work too. Okay, we've talked about proportions. We've talked about why cross multiplying works. We've used it to check if proportions are true. We've put variables in, it's the same process. And we've seen how to set up the word problems. We haven't talked about graphing, that's okay. If we need help, we can always do that next week. I have a game that helps review some geometry terms, and you can try playing it with a friend or family member if you want. I'm not going to require it. Let's look at the textbook before I say goodbye in 3 minutes. Make sure that you really are ready for this. So we are going to 4.4, which is 128. So we're starting with intro to proportions. Everyone looking at the textbook, by the way, since it's full screen, I don't get to see the glowing order. So it's defining proportions. Can you write things as proportions, putting them on top of each other? Translating sentences into proportions. Deciding whether proportions are true. All of this look okay after what we've done?
Yep.
Do some exercises. No X's yet, it's just checking if they're true or writing them. 4.5 is where you're actually solving them. Now we have some letters. We may have some negative numbers or decimals. As always, they tend to write multiplication with parentheses sometimes just to throw you for a loop. And then you have more homework in 4.5. All of this homework looks okay. The main tip is once you get to the word problems, read it halfway through and then stop. Put the words on the other side before you keep reading, and then you won't make a mistake. 4.6 has variation, and they could be a little clearer about this. When you have an example 4.30, then those things make a proportion. Then they have inverse variation, and that's when the things don't multiply. It's when you go across and they multiply to the same number rather than have the same unit rate. So if you look in the chart on 4.30, whoops, come back, 4.31, then each row multiplies to the same amount. Whereas with the proportions, each row divides to the same amount. So just heads up on that, go slow and work through the example problem, and it will make more sense. If we're stuck on that, we'll talk about it in a study session or one-on-one when you want. And then graphing is pretty much that they just made you study negative numbers and want to give you some excuse to do that. So can you put things on the coordinate axis? If you've never done this before, don't worry about it. We'll go over it slowly. I'm assuming most students at LCC have seen this a little bit, and you can graph points if you needed to. They have the slope formula where you plug things in. This should look like something minus something over something minus something. There was a homework problem I made you write out. It's just plugging things in that same kind of shape of an equation. So if graphing is tricky, don't waste time on it. Get help. Maybe I'll say wait for next class. Okay, I'm going to pause the recording.